Hello, in this lesson, we're going to talk about composition of sine and arc sine in different orders. When we talk about composition, okay, one of the properties, and we probably would remember that when, first of all, we can compose any two functions or any three functions, or have one function composed, one or two functions composed in different ways, different orders, right? In this study, we're going to talk about composition between sine and arc sine in different order. In other words, we're going to be talking about the composition of this form, right? F is a function, okay, and G is a function. Okay, G is a function. Okay, both are functions. Okay, when we talk about composition in this case, the sine, we're going to talk about that it's going to be sine function. And G is going to be arc sine. Okay, arc sine function. So now we know the domain and range of these two functions, right? Which we have done them, right? The domain for sine is all real numbers, and the range is between -1 and +1, right? To review that, let's just, I'm going to bring these review, right? These are the graphs, right? These are the graph. This is the visual. Okay, the purple, I changed the color to purple. So this is much easier for arc sine. The purple is arc sine, the blue is the sine. And this little box is what we discussed that is part of the sine and arc sine, these pieces inverse to each other, right? So we have that study. And we also have studied the domain and range, which we have a summary, right here. Okay, which is right here. So domain and range are being studied. Okay, all of these are being studied. But we also mentioned that this function, right? This function is rarely used. Okay, what is this function? This function is that a small piece. Okay, is that small piece? It's rarely used. Okay, so we're going to talk about these different cases when the composition of sine and arc sine are, are part of the are the questions. For example, we can compose F composite G. Okay, or G composite F. G composite F. Okay, and in our case, these composition will become F composite G will be F composite G of X, right? And in this case, it's G of F of X. We know those definitions. And then in our particular case, right? In our particular case, F is sine. So we have sine of G of X, which is arc sine. Okay, and the other situation, the next one, G composite F, which is going to be arc sine, of sine. Okay, so these are the two cases we're going to study. These are the two cases we're going to study. We mentioned that these two functions, right, sine function and arc sine function, they are not inverse to each other. Only this sine function and arc sine, they are inverse to each other, right? Therefore, these are not going to be equals to X without any additional condition, without any additional condition. Okay, so next so in this section, we're gonna study these situations. So after we have reviewed all of these situations, right? And remember, we're still on the stage, we're still studying functions, and we're still on the stage, right? We're still talking about the 3 pillars of trigonometry. And we only need to also remember, right? For sine function, we turn angle to ratio. For arc sine, okay, so for arc sine, we turn ratio to angle. We turn ratio to angle, okay? So I'm going to put this piece on the summary table, okay? So insert row. Wait, okay, so I'm going to put it here. Okay, I'm going to put it over here. So now sine, okay, is a function that takes input, which are angles that give it to sine and produces the ratio, produces sine ratio. And the sine ratio on unit circle is going to be y, or y over r, right? So it is a ratio. And arc sine, okay, which takes input, okay, input are ratio, okay, input is a ratio. So and one input is one ratio, and it goes through this function, okay, goes through this function. It produces exactly one. It produces exactly one angle, okay, which is A. Okay, but these A are very specific. The range is between negative pi over 2 to pi over 2. Okay, so with that understood, how about this other case? The other case is the same situation as sine. It's just in a smaller interval, right? And we also mentioned most of the time we don't use it, but here we still have it attached. Okay, we still have it attached. Now, okay, the first case we're going to study is that we're going to look at a situation. We're going to look at that situation when the chosen input, okay, the chosen input are from this box. The chosen input is from the box for sine, okay? So that's what we are going to consider before we move forward, right? So we need to understand, you see, this is also a review that the input X, right? So this is the flow. The flow says X is input to arc sine. Oops, arc sine, okay. Arc sine, okay, produces angle, okay? And because X is the input for arc sine, therefore, this X has to be in the domain of arc sine. The domain of arc sine is going to be from -1 to +1, okay? And the flow, okay, and the flow is like that. So the input is X, which is a ratio, will be considered as a ratio no matter what you enter. It has to be between -1 and 1. It produces exactly one output. And this angle is going to be in the range. It's going to be in the range of arc sine, which is right here, right? So this angle then will be, so on this flow, will be the input for sine. okay? And then in the end, it produces a ratio, okay? It produces a ratio. And of course, that ratio is also going to be in the range. It's going to be in the range for sine. In the second one, however, right? Because the input x is given to sine direct first, right? So on that flow, so this x has to be from the domain for sine, which are ratios, right? So even though they're both called x, right? So this x is really angles, it's really a, But suppose we still use x because it's after all just symbols, right? I'm just showing you how to identify what type of input we're expecting. So this x is going to be from negative infinity to positive infinity, okay? And so the flow, okay, is x is the input to sine, okay? It produces a ratio, and this ratio is going to be in the range for sine, the range for sine, okay? It's going to be in the range for sine. And that ratio in turn becomes become the input for arc sine. Okay, so the second layer of application of function is arc sine of that ratio, okay? And it produces an angle, okay? This angle is going to be in the range of arc sine. Okay, so that's the flow. Then some of you may say, hey, doesn't that equals to x, right? Doesn't that equals to x? Remember, right? Well, no, because f and g, sine and arc sine are not inverse to each other. They're not inverse to each other, okay? But then you say, well, these two functions are inverse to each other. You're right. Therefore, okay, so from this perspective, right? So when we have from here and from here, okay? So when sine of arc sine, when this is done, okay, right? For any x from -1 to +1, okay, for any x from -1 to +1, it produces an angle, right? The output is from -π/2 to π/2. And then sine take that angle as input, it produces a ratio. This one, yes, it's going to be x all the time. This is going to be true, okay? This one is true. Okay? And this other one is false. Why? Because x is from -infinity to +infinity. -infinity to +infinity. So what would be true? What would be true? Right? It would be true. I mean, this is a false. This is a false. Okay? Or if you don't attach anything, that's false. This is a false. Okay? With or without that interval specifics. However, it can be true. It can be true if this x is from -π/2 here or 2π/2 there. In other words, if the x is from here. Okay, this is because sine and this, when we have this assumption, we are referring to this sine. And this sine and arc sine are inverse to each other. That's why this piece is true. And this piece is not true because x is from negative infinity to positive infinity. Okay, these two are not inverse to each other. Then you say, how about the first one, right? The first one is true because the way it operates, right? Sine can only apply to the output of arc sine. The output of arc sine is from negative pi over 2 to pi over 2, right? So out of this, right? And then you apply sine, of course, you always get that. Therefore, this is true, that is false, with or without it. Okay, so even if you without it, it's false. This is a false, but this is true. Okay, so this has also confirmed. Okay, this has also confirmed. What is it confirmed? Confirmed. Okay, what is being confirmed? In our previous chapters, we have talked about if we have, right? If, right? If, wait, what am I doing? If f and its inverse, okay? F and its inverse, F inverse, right? With their specified interval of domain and range, right? If it has inverse, its inverse will satisfy this condition. F composite F inverse of x is going to equal to x, okay? Where x is from the domain of F inverse, okay? From a domain of F inverse. F inverse domain, which is going to be domain of F inverse. Okay, and that then F inverse composite F is also going to be x, provided x is from the domain of F. Domain of F. Okay, so in our situation, right? In our situation, let's take a second look of why this is true. Why this is true. RF, okay, RF, right? Let's assume that RF is arc sine. Okay, RF is arc sine. Okay, RF of x is arc sine. Okay, its inverse. What's the inverse? Its inverse is sine x, and x is from that interval. Okay, which is that small piece, the blue piece, okay, in the box. Okay, the blue piece in the box. Okay, so that blue piece in the box okay. All right, so this is true. Let's see how this applies to our situation, right? This is true because when we do F composite F inverse, that's going to be what? What would that be? F is arc sine, right? F is arc sine. Okay, So arc sine of sine, right? Arc sine of sine, where x is from the domain of F inverse. The domain of F inverse is going to be this guy. There, right? You can see that's what we got for this piece, right? That is true. The next one, the arc sine of sine, which is F inverse of sine, sine, which is a sine because F inverse is sine, right? So that would be sine of arc sine x, and x is from the domain of F. What is the domain of F? The domain of F, this x belongs to where? Belongs to from -1 to +1, right? So this other x, even though they're both called axes, they have their own domain and range, and this x is from where? Is from -1 to +1. Okay, so that's why these two statements are true. So compare, right? Compare with that. So you see, this piece is that. Okay, these two are the same. And this piece is the other one. So we got these two true statements. You can see the consistency between a one-to-one function and its inverse. They still satisfy that property. Always. And in our specific case, right? In our particular case, we got these two true statements. Okay, the first one is right here, right? And the second one is this guy. The second one is this guy. Okay, x is from -1 to +1. And if we don't have any condition attached to it, well, that is false. Okay, so this piece is false and that piece is true. Okay, and this piece is true if x is always from -1 to +1. Okay, all of this is because the discussion we had, in the lecture before this one about creating a new function, which is the blue piece in the box, and that function has inverse, right? Or truncation of the sine curve on both sides, or the way we talk about, which is the unit circle with quadrant 2 and quadrant 3 removed. Okay, so now, for this reason, right, we always have to, on the hand side, know that this blue and the purple are not inverse to each other, but only when specified, right? Only when specified, and that will be true. Okay, that will be true. All right, so let's try some examples. I got examples for you. Okay. Got examples for you. Okay, so we're gonna take this along with us. I'm gonna take this along with us, and we're gonna start doing some examples. To demonstrate the use of it. Okay, and we also want to see that you see only these two functions are mostly used. Okay, so you never have to ask the question when I use the word sine. You never need to ask the question, oh, is this the old sign, new sign? There are no such words. Whenever we say sign, we refer to this sign. We refer to the blue sign, unless otherwise specified. Unless otherwise specified. Okay. Now, let's look at some examples. The first example we have here. Okay. Example number 1. We got sine, arc sine of 3/5. 3/5. Okay. If we understand that this property is applicable here, right? Because the input is 3/5 and 3/5 is in the interval between -1 to +1, and the answer is straightforward. You don't have to do anything. You don't have to do anything. Okay, you don't have to do anything at all. However, right? What if we're a little confused? We're not sure. Okay, what if we're confused? We're not sure. Okay, okay, so there's another way to do it. Okay, in case of uncertainty, right? For example, I'm not sure what I'm doing. Okay, I only know the domain of arc sine and the sine, which is arc sine domain is from -1 to +1, and the domain for sine is from -infinity to +infinity. So I only know these two curves. I kind of not certain about, you know, all the details about the making of arc sine, etc., etc. And we can do it this way. Okay, so I'm going to show you how we do it and the rationale behind it. Okay, so we can do it in 2 different ways. First of all, we're going back to the basic ARD. Okay, ARD. Okay, so I'm going to set up my rectangular system. Okay, so there's no need to panic, right? So my rectangular system, in this system, I have my unit circle, right? You don't have to remember any point on the unit circle either. Okay, you say, oh, I forgot all of those. That's fine, that will work as long as you know the 3 pillar. Okay, as long as you know 3 pillar. So you still have to know the basic, you know the definition. Okay, you still know the definition. Okay, so what do we do? Well, in this case, I want to show you how this whole piece, right, this whole idea, okay, this whole idea about the definition, the importance of the definition is going to play a role. And that's also explain to you why it is important, okay? So we're gonna do it from inside out. Right? So next, we don't know the answer, pretend, right? Pretend we don't know the answer. Okay, so I put it away. But I know the 3 pillar and I know standard position. So I know that arc sine is going to give me an angle. Okay, so we assume that arc sine 3/5 is going to produce an angle. This angle, I'm going to call it theta. Okay, provided you know the domain and range for arc sine, then because this ratio is positive, right? Because this ratio is positive, therefore, we know that sine theta is going to be equals to 3/5. And what is more, we know the range of arc sine, so this angle is going to be in this quadrant is going to be in 0 to pi over 2 on the positive side. What does that mean? It means that this angle theta is measured counterclockwise. So we know sine theta is 3/5. Okay, 3/5. So what does that mean, right? So all of these concepts are coming to our mind, right? So this angle is going to be measured from standard position counterclockwise. I don't know what theta is. Okay, I don't know what theta is. And you don't even have to punch in the calculator. No need for calculator. But I do know that this theta is going to be in the first quadrant because 3/5 is positive, right? Now, so this is theta. Okay, so this is theta. Right? And is sine theta is 3/5. So we already have the answer because this piece is theta, right? So let me show it to you. So you can see we already have the answer. Sine, and this piece is theta, right? Because we assume this is theta. So that's sine theta. And what is sine theta equals to? It's equal to 3/5. Okay, so that answer is right there. That answer is right there. You get it? So if you still understand the basics, which is ARD, you can still resolve this issue without any problem, Okay, so let's look at another example. Okay. Example number 2. Okay, example number 2. So here we have a sine of arc sine, parentheses, -3/4. It's not a special angle once again, 3/4. What does that equal to? Well, you can see this property applies once again. This property applies once again, right? And hold on, I'm going to put a parenthesis this way, okay? Now, if we recognize that these two are in the same form, right? And x, which is in the place, the number in the place of x is a value of -3/4, and this number is between -1 and 1. So the answer is obvious. The answer is -3/4. You're done. You're finished. Once again, however, right? It's another however, right? Another way. Okay, another way. I present you with the other way because I want to address the importance of knowing these basic information, which are very important. Another way is that pretend we don't know the answer. So pretend we don't know the answer. And we also forget about this, right? So what you can do is we start from here. Okay, we have our unit circle. Hold on, what am I doing? I meant to bring that picture. I bring that coordinates with us, right? Pretend we don't know, we kind of forget about this. We're not sure about this, right? Because sometimes we do get confused, okay? At least, sometimes I do get confused. Okay, so in this case, right, we also understand that this piece is going to produce an angle, okay? So we assume this piece is going to be an angle, okay? This ratio is not a special ratio, but it does produce an angle. And this angle is going to be between -π/2 to 0, right? Because it's a negative ratio. So the angle is going to be measured clockwise. To understand this, I want you to go back to see that lesson I talk about that. I talk about those, you know, why the rationale behind the making of arc sine. Okay, so I'm going to bring that up again. So now you can see, because the ratio is negative, right? And the output for arc sine can either be between 0 to negative pi over 2 to or 0 to pi over 2. From 0 to pi over 2, those are all positive blue numbers, positive ratios. And beneath the clockwise, there will be negative sine ratios. Therefore, as a result, we know that this angle theta, this theta is measured clockwise. So this is theta. Right? Now, with that understood, this statement tells us the angle theta, we apply sine to it, is going to equals to 3/4. It's going to equal to 3/4. And here we go. We already have the answer right here, right? Therefore, right? Thus, so this piece is equals to, right? I know this is going to mess us up, right? So this piece is going to be the way theta was set up, right? You guys saw that. So, so this is going to be, this piece is theta, right? So this is going to be sine theta. And what is sine theta? Sine theta is negative 3/4. Right? If you would recall the table we have done, okay, for the special ones, for the special terminals and special angles, right? So once again, I want to bring you the unit circle as reference. Okay, for these two examples, right? The first example and second example. We know that for arc sine, right? Well, arc sine is considered, right? We chopped off quadrant 2 and quadrant 3. For the positive ratios, those are the output for arc sine that produces positive angles. Okay, so 3/5 or 3/5 is going to be one of them. 3/5 is going to be one of them. The terminal is going to be somewhere between these special blue numbers. And negative 3/4 is one of the negative ratios along this, along this piece, right, with terminals. And that's going to be somewhere. It could be between here or there. I think it's probably over here, right? So these angle for negative ratios, the output for arc sine is going to be between negative pi over 2 to 0. See, that's how I made that judgment call. And for the first one, for 3/5 as a ratio, the angle is going to be between 0 to pi over 2. I hope that makes sense, right? So we have addressed those issues, and now this is time that we apply those situations. Okay, now a couple more examples. Let's wait. I'm going to erase that, right? So just to illustrate, right? If the ratio is 3/5, right, which is the first example, 3/5. 3/5 is approximately, it's a 0.6, right? It's probably here. And on this point, imagine this point, right? Imagine this point crossing the unit circle, and there's a point, okay? There's a point, and that point is going to be, I'm going to mark that point for you, okay? And that point is going to have a red number. Okay, we don't need a red number. We could find the red number if we wish, right? But we definitively have the blue number. The blue number is 3/5. Okay, the red number, if you want to find it, we can find it, which is this is the piece. Okay, the red number is not needed. If needed, can we find it, right? And the blue is right here. This is the blue number. So we know 3/5 is the blue number, and we need the red number, and the hypotenuse is 1. We can find the red number easy. It's actually 4/5, but we don't need it here. So therefore, we're not gonna really do that. But for your information, it's really 4/5. It's 4/5, right? So that was the first example, right? The second example, when we have the ratio -3/4, okay, -3/4. So this is going to be negative angle. So terminal somewhere, I'm going to use a different color. Okay, so let me use a different color. There. Okay, so I'm going to use a different color to draw that terminal. That terminal is going to be approximately -3/5 is -0.75, right? I think it's going to be somewhere here, maybe here. Okay, and then there's a point of crossing the unit circle, right? So how about this point? This point, if we are to mark it, that point is going to be, there's a red number and there's a blue number, right? And what is the blue number? The blue number is going to be -3/4. So -3/4. The red number, okay, the red number, we don't need to find it, but if we want to, we can. Okay, the red number basically is this piece. Okay, that's a red number. And we already know the blue number, right? We already know the blue number, right? And so this is the blue number. Can you find the red number for the star point? Of course you can, right? So this is a -3/4, and this red is unknown, which is the number we need here. But we don't need it here for this question, okay? So you can just use Pythagorean theorem to find it. I'm going to leave that for you. Just if you have that curiosity, okay? Our question is done. We don't need to do it to find this red number, but for your curiosity, I encourage you to do so, because in the future, we might need to do that, okay? So these two examples demonstrate that either way, okay, if we know the basic information, okay, we know ARD, we can always resolve the issue, whether we know those new formula or not, okay? All right, so let's move forward. I'm going to give you, some more examples. Now, okay, these examples is going to be like this. Example number 3. Okay, example number 3. And this is how it goes. We have arc sine of sine of pi/3. Pi/3. Okay. What do we do? Well, if you know this property very well, it applies to it right away, because you can see they have the same form, arc sine and sine inside, and x which is replaced by pi over 3, is inside this interval. And then the answer is very straightforward. The answer is pi over 3. You don't have to do anything. All you have to do is understand those basic facts, and you also know this formula very clearly, okay? However, what if you don't? What if you don't? Okay, if you don't, in this situation, it's actually, it can be done without using this identity. Okay, so I'm going to show you how to do that. Pretend that you don't know this identity, right? So we have, so I'm going to show you another way. Okay, pretend we don't know that extra information. We just know ARD, right? And we kind of know the unit circle provided that you do, okay? And we will do it from inside out. We do it from inside out. How do we do it from inside out? Because we see pi over 3 is a special angle, right? It's a special angle. So this unit circle can be very useful for us, right? And so we do the ARD. So we do it from inside out, right? When we do it from inside out, we're gonna have a arc sine. It's waiting outside, right? And sine pi over 3, we know pi over 3, how pi over 3 is measured. Okay, from standard position, and it terminates right there, right? And you take the blue number, and we take the blue number. The blue number is √3 over 2. Okay, so this shifted places, I'm gonna just clear that, right? And then, so we have done the inside. When we do the inside, we basically apply the, we are on the stage set, and we apply the definition. We apply the definition, which is the blue number, right there. Now, okay. So we have that terminal there, right there. Okay, and next we're dealing with arc sine. For arc sine, we're going to take this ratio, and we have this ratio, right? And we know that this answer has to be where? Has to be between negative pi over 2. So you just think out aloud in your mind. You don't have to show it, but it would be nicer if you show it properly. Okay, if you show it this way, right? In your mind, you know that you're expecting an angle for arc sine √3 over 2 between negative pi over 2 to pi over 2. In particular, it's going to be a positive angle. In particular, it's going to be from 0 to pi over 2, okay? It should actually be open interval. Open interval works too, whether it's a closed bracket or that doesn't matter. And that's going to be angle. And then we know that these quadrants, quadrant 2 and quadrant 3 are out, and therefore you also get the same answer, which is pi over 3. Does that make sense? So you can reason these steps to get the right answer as well. Okay, so now let's look at another example. Okay, let's look at another example. And this other example, okay, let's look at the other example. This is going to be example number 3. Example number 3. No, example number 4, sorry. Example number 4. Okay, and this one we have sine, arc sine. Okay, I have an arc sine. Let's do the sine of arc sine. Arc sine of 3/4. Okay, what do we do? What do we do with that? Well, in either way you do it, you look at this special formula, this special formula. None of them apply. This one seemed to be closer to the form, which is similar form, but you notice that input, the number at the place of X, that placeholder is outside the domain for arc sine. Therefore, what do we say? We say it's undefined. Okay, undefined. Okay, so let's do some other more interesting one. Okay, example number 5. Okay, it's the questions is getting harder and harder. So we have arc sine, and then we have a sine. Okay, in this case, we have a 3 pi over 4. 3 pi over 4. Okay. If you're still aware of one of these two formula, you realize this one is closer to our form. It's exactly the same form. Can we apply this identity? The answer is no, because 3 pi over 4 is outside this interval, which is outside the box. Outside the box. Do you see that? Right? Outside the box. Therefore, we cannot use. Okay, so I'm just going to put a note there. Okay, cannot use this identity. Then what can we do? And as I mentioned earlier, you don't need to worry about this sign, which sign it is. Is it old one, new one, you know, constrained one with constricted? You don't need to ask that question, because the fact that we write it this way, we have already told you this is just the sign as we know it, which is defined from negative infinity to positive infinity. There's no need to ask those questions, right? In our situation, in almost your all of the situation you are going to be dealing with this kind of composition, you're dealing with the blue and the purple. Okay, dealing with these two. If it's in the box, it will be mentioned as such. Okay, so now what do we do? Well, in this case, right? In this case, you can let me bring that unit circle with you if you like to see the process. And I believe most of you probably don't need this kind of you probably have finished this by this time. Okay, but I'm going to show you and emphasize the importance from inside out. Okay, from inside out. So 3 pi over 4. So we first deal with the inside. Sine 3 pi over 4. ARD. Okay, so why we mention these ARD? Because we're talking about any situation. It doesn't have the special angle. In the case it's not a special angle, you will handle it the same way. Okay, so we're gonna measure this angle counterclockwise, because it's 3 pi over 4. It terminates here, right? And that blue number we have here is √2 over 2. √2 over 2. Okay. Hold on. Okay, so we're learning a systematic method, right, which uses ARD to solve our questions. So here, see, even though we mentioned that terminal for 3 pi over 4, right? We have that terminal 3 pi over 4 right there, right? So we got the ratio, right? We got the ratio. Now we're dealing with the arc sine. Okay, when we are dealing with arc sine, we know that quadrant 2 and quadrant 3 are out. So what are we going to do with that ratio, √2 over 2? Well, we have a twin brother on this side. We cannot use this √2 over 2. We can use this other √2 over 2. Okay, So we know this ratio. So we know this ratio, blue ratio here. And what is the angle that arc sine can produce? Is going to produce an angle, because we know this is the reason for why we need to know the range for arc sine, which is negative pi over 2 to pi over 2. In particular, because this is a positive ratio, and you can safely say this is between 0 to pi over 2. Does that make sense? I hope it does, right? Because remember, you look at these blue numbers, right? For positive ratio, the angle will be measured counterclockwise between 0 to pi over 2. For negative ratios, it's going to be between 0 to negative pi over 2 and measured clockwise. So in the end, so we want you to think about all these things we actually talked about before, now as they are applying in the real situation. So the answer can only be pi over 4. No other. Okay. Common mistake. If you give the answer, okay, some people give the answer of pi over 4. And these other students can also give me the answer of 3 pi over 4. Common mistake. Well, you know this is a common mistake, right? If you gave such answer, okay, how many points are you getting? You get 0. You get 0. Why? Why is 0? You say, oh, I give you a right answer. Sure, I give you the wrong, and I give you a wrong answer, and I give you a right answer. Why couldn't you give me half the point? The answer is no. You're not getting any point, because for arc sine, taking any input, right? The ratio between -1 and 1, you know you should get exactly one answer. By giving such answer, that means you're not clear about the definition of function, which for each input, it produces exactly one output. So you're confused with function definition, okay, not clear. And much less to say that for one-to-one function, right, you are not clear about. So you're not clear about function definition. You're also not clear about one-to-one function. And of course, you're going to get 0. Okay. I think that's all for this lesson. And I hope it's not too long, because I think last lesson was a little too long. You can, maybe let me know of any questions. Okay. Thank you for watching. Until next time.